Namastey Coders. I hope you are fine, doing well in your life. So today is 13th Feb and we are gonna solve the problem of the day, right? So the problem is, this is a medium type of problem and topics are array heap map simulation. Okay, so before solving this problem, I will tell you how do we proceed, right? So we will discuss the details, right? So this is our standard method to solve any problem. So first we will discuss the details. In details means what is given to us, what is asked, and all other details, including the constraints and all, right? Then we will go through. We will try to solve this problem using native approach. And what native approach is? What is the first approach which came in my mind or which came in our mind? What is the most basic approach, right? So that we will do. We will discuss the native approach. Then in the last, we will optimize the native approach to find most optimized approach, right? So this is also the basic, this is also the standard method to solve any problem in any interview, right? So we will do these three things, right? So what is given to us? Let us discuss that. Okay, so what is given to us? We have given a zero indexed integer nums, right? We have given a zero indexed integer nums. So this is given. Okay, and an integer k. Okay, we can do these operations, right? So in one operation, what we can do, we can take two smallest integer of in the num. Okay, we have to remove these nums, and then we have to add this. Fine. So those who are who have a practice of solving DSA's problems can directly think of the most optimized approach for this problem, but we will go through these standard procedure, right? So we have given this array, right? What you have to do, we have to do these operations n number of times, and so that all elements of the array. Okay, so we have to do these operations n number of times, and till that so n number of times till all the numbers in this num will become greater than k, right? Okay, so what will you do in the first place? What we'll do, we will extract two smallest element from nums, so which is 1, 2, right? Then we have to remove these, so the array will be like this, and then we have to add minimum of x comma y, which is 1 into 2 plus 2, max of x comma y is 2 plus 2 equals to 4, so we have to add 4, so 4 will be added. Then we have to extract smallest two numbers, so in this we have done one operation. Then in the second operation, we have to take two smallest element, which is 4 and 3, so this is like 3, 4. We have to remove them, so we will remove 4, we will remove 3, and we will apply this. So for this we have 6, 3 into 2, 6 plus 4, this is 10, right? So we will add 10. Now all the elements in this array is equals to k or greater than k, so we require two operations, right? So this is what asked, right? Now in the native approach, what can be done, right? How to solve in the native approach, right? So let's discuss the native approach. do what is asked, right? Do this operation n number of times. Okay, so first find two smallest elements from the array. So this will take n two iterations, right? So I can say this has the time complexity of n, right? Then we will do these operations. Remove this will take O1 and this will take also O1. So two other operations, right? And third, append the result, right? So we have to do this. This all will take n time, O(n) time, right? And we have to do this multiple number of times. So do this again and again till all the elements become greater than k. Okay, so what is the time complexity? So doing this again and again will also take n. We can say n, right? So the total time complexity, we can say n square. And space complexity is nothing but 1, because we don't have to take any other space, right? So how to solve this? How to optimize this, right? So can we somehow get, so we can see that this operation is taking n number of iterations, right? We have to iterate through this array again and again to finding the smallest array. So is there any data structure available, or is there any technology or anything or any approach, or I can say, is there any algorithm which can be used here to reduce this process, or I can say using which data structure I can do this in O1. So I hope you have the answer. We can use heap map, we can use heap, right? So I hope you know about the heap, or I can say heap priority queue, anything, right? So let me explain what heap is. So heap is nothing but a container, okay, which has always the minimum value at the top. So let's think about a container. Okay, let's think about a container. It has a gate. Okay, you put anything inside this container. Whenever you ask for its topmost element, right, it will always throw the minimum element present in this container. So this is the property of heap. I suggest you to go through some good vlogs of heap, which will that will give you a better understanding of heap, how heap works. But in this problem, it is not required to know how actually heap works. But the only thing is required is only thing required is heap throw the smallest element outside. Heap throw out the smallest element present inside the heap, right? So that is all needed, right? Because we only need the two smallest elements, right? So let's write the rules, right? Steps: put all the elements inside the min heap for minimum element and max heap for maximum element. I will explain you the concept of mini heap and maximum heap in some another video. So if you want that video, please you can comment, you can ask in the comment section, right? So elements inside the mini heap. So this will take this will take O(n) time complexity, right? Then what we'll do, take 2 elements out of the heap, take 2 elements out of the heap. This will be done in, so that will those will be the smallest element of the, what I'm doing this here, element of the nums of the array. So when I put all the elements inside the heap now, so it will, and whenever I ask for the 2 elements, right, so it will always throw the 2 smallest element of the heap, right? Do the given operations and put the result into the heap. If the topmost element of heap is greater than equal to k, we got the answer, right? So if we have the topmost element of heap greater than k, that means all the element inside the heap is bigger than k, right? So that is all we need. We got the answer, return the number of operations. So this required O(n) and this also required O(n), but this is not the I can say loop inside the loop, right? These are consecutive loops. These are not what the word is, nested loops, right? So so in this we are using 2 nested loops. That's why it is the time complexity n square. But in this we need only 2 consecutive loops. So the total time complexity will be n square. So not n square, sorry, my bad, 2n, but I can say n. And total space complexity will be n for storing the element in the heap, right? So let's code it. Oh, I got confused how to use how to implement heap in Python. So let me check it. Heap in Python. So heap is used using heapify method, right? Okay. Heap q dot heapify h. Okay. Sorry. So we have nums heap q dot heapify nums. So this is how we are gonna make nums a heap. Okay, now for true, our answer is currently 0. We are checking x1 equals to, so if length of nums, right, if length of nums is smaller than equals to 1, so we cannot take 2 elements, right? Return if nums, so return 0. We cannot do anything, right? So x1 is nothing but how to heap pop h, right? Heap pop nums x2 is again heap pop nums while length of nums is greater than 1. If length of num is equals to 1, we will return answer, right? If x1, right, if x1 is greater than, sorry, So I will do it here. If x1 is greater than equal to k, so we will get an answer. If the topmost element of heap is greater than k, we got the answer, so we will get an answer. We will do the operations, right? Temp is equals to min of x comma y is simply x1, because x1 into 2 plus x2, right? How to push inside the heap q dot push, heap q dot heap push in nums. We push temp and we do answer plus equals to 1, return answer. Yeah, test case is getting passed. I think we have to return -1 if so. Let's see if there is a case. So yeah, this is getting passed in first attempt only. So I hope you understand this approach. I have tried to explain this well, but if I have stuck anywhere, please let me know in the comment section so that I can work on that. So that's all in this problem. So this is the problem from LeetCode problem of the day series, which we are solving daily problems and uploading the video in the LeetCode problem of the day playlist. Along with this, we are also solving this LeetCode 75 series. So the playlist link is given in the description box. You can go through those videos also. Along with that, I have created a WhatsApp channel, WhatsApp group, where we can discuss multiple things regarding any doubt in any problem. We can also discuss multiple things about any project, any technology, or anything, right? So if you want to join that channel, you can click on the link given in the description. So that's all from my side, guys. Thank you for watching this video.